Hello and welcome to the webinar. Today's webinar title is Exploring Disaggregated Broadband with Capgemini Engineering and EDGECORE Networks. Today we have Kalimani Govindarajan, AVP Product Management from Capgemini Engineering, and Nanda Ravindran, VP Product Management from EDGECORE Networks to speak on this topic. In this webinar, initially, we will look into the trends and future of the broadband access disaggregated ecosystem, and later Kalimani and Nanda will present their company overview and solution for the disaggregated broadband segment. There has been huge surge in demand for residential broadband after the COVID-19 pandemic situation, and this has resulted in new fiber deployments and in expansion in some by the service providers across the globe. The research reports indicate that phenomenal growth of the fiber deployment is here to stay at least for the next 5 years. It is just not residential broadband, but business and wholesale segment is growing thanks to the wide range of PON technologies to offer. According to the analysts, the global fiber to home market is expected to reach around whopping $30.3 billion. There are various forums and industry bodies that are involved in the disaggregated the broadband technology ecosystem. The first one is the Broadband Forum, called the BBF, has been in the forefront of defining the standards for broadband access and has defined several projects to address the open and disaggregated networks. For example, Open Broadband Access Abstraction, OBBAA, defines open interfaces associated with the access network devices such as like OLT. The next one is Open Compute Project, OCP, provides ecosystem to promote individuals and organizations to share their hardware design for the white boxes, which is a key part in the disaggregated solution. Next is Open Network Foundation, the YNF, led by the Operator Consortium, has been promoting many open source projects, particularly SIBA and Volta, leveraging the white box hardware and open source software. Lastly, the Telecom Infra Project, TIP, has launched a new group called Fixed Broadband that will focus deeper into the fixed access domain, covering the access, broadband, and service gateway technologies that operators need to build and operate their fixed line networks. This is very significant for operators because TIP has been very successful in building a strong disaggregation ecosystem for the cell sites access, aggregation, and core networks. Thanks to the TIP and its ecosystem, we are seeing a growing acceptance of deploying the disaggregated solution by the operators. Let's look at some of the major challenges foreseen by operators for a successful rollout of disaggregated broadband deployments. A mature ecosystem consisting of forum, technology, and standards and vendors is a prerequisite for any successful deployment of disaggregated solution. And this will ensure that software and hardware from multiple vendors will work seamlessly. For a brownfield deployment, the operator would want to run legacy and new deployments in parallel. And the key challenge is here to make the new disaggregated solution interwork with the legacy deployments. The third major challenge is, since the disaggregated solution comes from various hardware and software vendors, the challenge for the operator is to manage and have a unified view of the network rather than managing the islands of networks from various vendors. Well, let us hear from Kalimani and Nanda on what they have to offer on disaggregated solution. Over to you, Kalimani.
Hello everyone, welcome you all to the webinar on next generation broadband. I am Kalimani Govindarajan, Head of Network Software Product Management at Capgemini Engineering. Capgemini is a global corporation headquartered in France, present in 50 plus countries, 18 plus billion revenues, and in multiple lines of businesses. Capgemini Engineering focuses on product engineering R&D, system integration, and product support. We are number one in engineering R&D, and telecom's significant focus with 20 plus years of investments in licensable software frameworks and new technologies in networking, 5G wireless, cloud, edge, and automotive. We have been working with the network equipment providers and telco operators to build a variety of solutions in the past 20 years, and most recently in the white box ecosystem as well. Now I'll hand it over to Nanda Ravindran to introduce EDGECORE networks and continue the webinar.
Yeah, thank you, Satya and Kalimani, for the the great introduction and discussing an overview of Capgemini. So let me start off by giving an introduction about EDGECORE, and then we can talk more about the disaggregated broadband solutions that we will be reviewing today. So EDGECORE is an independent company since 2004. It is a fully owned subsidiary of Acton, and we have a full portfolio of hardware platform for for the telecom space, for the data center enterprise. We have shipped over 80,000 switches last year, and we have done these deliveries for large tier ones and several smaller customers. EDGECORE has a worldwide presence. We have worldwide sales and support. We are headquartered in Hsinchu, Thailand. EDGECORE is an open networking solutions provider. So we follow a very flexible business solutions model. We understand customers need different solutions and different delivery models. We work with several NAS partners, distributors, and system integrators and see what fits best for the customers, and we try to work and provide that. EDGECORE is a leader in open and disaggregated networking. We participate and we collaborate in several open networking forums, such as the OCP, ONF. In the bottom, as you can see, EDGECORE not only participates in the service provider or the telecom market, we are also a key participant and provider in data center enterprise wireless. We also support the NAS software, Sonic, which is also a key part of our portfolio. So let me talk about the disaggregated hardware and architectures that EDGECORE provides. EDGECORE has an entire suite of disaggregated open networking solutions. We start with the access and the backhaul. We have the GPON and the XGS-PON platforms. And then as we move up, we have the disaggregated cell-site gateways or the access routers, several of them. And then we have aggregation and core router starting from 800 gig up to 4 tera. And those core routers can be stacked and in a spine and leaf configuration and reach up to 96 tera. We also have a packet optical transponder called a Cassini. It is a modular transponder. It is based on the latest coherent optical technology, and it has applications in long distance, long haul, or mobile backhaul applications. So now let's come and talk about disaggregation. So I think I will focus my discussion about disaggregation from a hardware perspective, and then Colin later will follow it from a software perspective. So on your left, you can see a traditional chassis-based OLT platform. It could be a GPON or XGS PON with PON line cards. And then the chassis would have a switch fabric in the back plane or in the mid plane. Then you would have control card hosting the control plane software. So in this model, everything is tightly integrated. The hardware and software are custom made, and the operator or the service provider who's going to deploy this does not have much of a choice. Will have to install the entire chassis and then decide on how many line units he needs and deploy it. But the first level of disaggregation that you see on the right is that the chassis-based architecture has been split up. The PON OLTs have now become white box OLT hardware, and then the switch fabric has become the top of rack switches. You could have a number of them depending on the capacity. And the control plane software that resided on the control card could now reside on the white box OLTs. So this, we call it as an in-box OLT, where we have disaggregated the hardware, but some of the software components reside close to the hardware, like in the previous model. The management, the SDN-based management, it is printed out. Yeah, this is the first level of disaggregation. Now let's move on to see, how can we disaggregate further. So this is disaggregated with a level of virtualization. So we have disaggregated the hardware, but the software also has been disaggregated. As you can see, the software on the OLTs is now a very platform-specific software, which is a thin layer of software corresponding to the hardware, but the software has been abstracted out. As you can see, the OLT control plane and the control plane for the top of the rack switches have been abstracted out. So this enables a much higher level of abstraction and virtualization, extending the disaggregation model further. So let me move on, talk about architectures where, the disaggregation would apply. So here, from an EDGECORE standpoint, we want to show an hardware architecture which is fully redundant from a switching and control plane perspective. You can see the OLT white boxes at the bottom have been put out, and the service provider can scale them horizontally based on the needs. Likewise, the next level is a number of switches, leaf switches, which can also be scaled horizontally depending on the requirement. Likewise, on the spine switches on the top. So EDGECORE has a number of platforms depending upon the port speeds and capacities. Listed a few of them here for the spine and the leaf, but there are a number of options that meet different needs of the customer. So, but what are the key components that make them open and disaggregated so that any kind of software, which Capgemini is going to talk about later, can be instantiated on these hardware platforms, and the necessary services for the customers can be provided. First one, it has to be an open platform. Hardware has to be an open hardware. The model has to be that they are white boxes with a level of platform software on them, some BSPs, and then the component is that it has an open networking install environment, the ONI, the ability to install the open networking Linux. So we'll talk a little more about some of the hardware that I've listed here. So the key point with these, with those hardware is to illustrate that what are the internal components in the hardware that would be needed to make the platform open, make it an open hardware. So as you can see, the first platform from an OLT standpoint that I want to talk about is the 16-port XGS PON. It is based on the Broadcom enabled chipset for the PON MAC functionality, and there is a Qumran AX as well for the switching. So these are key components. They are off the shelf and they are industry leading, and any open hardware would need such a capability to be able to perform and satisfy the needs, satisfy the requirements of any disaggregated broadband solution. So the next platform is the 64-port PON OLT. It is again based on the Broadcom chipset. Rest of the specifications are pretty standard. These are required for any kind of an hardware, whether it's a traditional or disaggregated. So we are coming up with the with a combination of the first two. It's a combo OLT where you could either have a 16 XGS PON ports or a GPON port. This gives customers a level of flexibility that that enables them to deploy both models on the same platform. So the combo OLT is based on the latest Broadcom Aspen chipset, and the product also comes with the Qumran AX switching silicon. So these are the different disaggregated OLT platforms that are possible. So the next platform, I mean, from a switching standpoint, or a top of rack switch, is the spine and leaf here. We have listed a couple of spine and leaf switches. They're all based on the same switching silicon. As a spine, we have 400 gig ports and several hundred gig ports, and aggregate several traffic from several OLTs. The chipset here is the Broadcom Qumran 2C chipset. It is 2.4 tera, well capable, and the leaf has an TCAM. The TCAM enables a number of subscribers' ability to classify and provide the required QoS treatment. Both the platforms have synchronous Ethernet and version 2 timing solutions. I mean, the takeaway from this is that both are optimized for the spine leaf architecture, and they support giving maximum flexibility for the customers in a disaggregated architecture. These are smaller version of the switches I just discussed. These can be used as leaf switches depending on the broadband capacities. Customers and service providers can choose these platforms. These are again based on Qumran AX chipsets, and they have different combinations of 100 gig, 25 gig, and 10 gig port interfaces. And again, these platforms are temperature hardened, so these service providers will have the ability to deploy them outdoors. And let me move on to another leaf switch. So this is a pretty high capacity leaf switch. It's based on the XGS family. This is 3.2 tera. So for a solution where you need several hundred gig ports to be aggregated towards the core network, this is an ideal fit for that. So let me move on to the next slide. So Finally, I want to summarize the benefits of disaggregated platform. One is a control. So essentially, the customers or service providers now have control over the different hardware platforms, whether it is the OLTs or whether it is the spine and leaf switches. There is an immense flexibility and control over the best of breed solutions that customers and service providers can avail. And is the innovation. So the customers can look at different options from different vendors. They are not limited by closed hardware and software solutions. They can go and get the best of breed, best features that they need, and this will help them to innovate much faster than their competition. Third is that it is non-proprietary and it's open, so they are not limited by the hardware network or the software solution. They have the ability to swap them out depending on their needs and network needs. Finally, the solutions are pretty optimized. The chassis, the architecture, chassis based, they're optimized for several different applications. But when it comes to the aggregated model, they are optimized for a single application, making it really cost effective, being giving the lowest TCO savings compared to any architecture. I think with that, I will conclude my summary in terms of the benefits of disaggregated broadband platforms, and I will hand it off to Kalimani to go over the software aspect of discussed. Kalimani, please take over.
Thank you, Nanda, for the presentation on the OLT disaggregation model and EDGECORE support for different OLT, TOR, leaf and spine switches. I will now cover the other piece of the puzzle, that of software and management. There are a number of questions which typically arise when operators consider the disaggregated OLT model, and I felt it's a good starting point for our discussion. Questions such as what are my hardware architecture choices to disaggregate? For example, should I choose a white box OLT versus a switch with a SFP OLT? Do I need to virtualize the OLT software completely, or can I still use like a traditional OLT, like what Nanda mentioned, in-box versus virtualized? How can I take advantage of technology advancements, like a new PON technology, for example, Hobo PON or anything else, newer higher capacity switch, functional difference, for example. And then with respect to ecosystems, what is the software ecosystem that I need to go with to address different use cases? How can I address use cases like, say, front haul transport, which needs timing? How can I address scenarios with, say, low density subscribers? Can I have a self-contained OLT with a distributed BNG functionality as well, like something like a local gateway? And finally, on the management, how can I take advantage of productivity tools like automation, intent, analytics, etc.? So lots of questions, and let's see what we can address here. This is a typical next generation fixed broadband network. But if you look at some of the key tenets that we can draw from this, it is evidently disaggregated, as in hardware software separation, but then it can also be virtualized. It is not a necessity, but it can be virtualized. And it can be distributed as in a blade OLT versus a chassis OLT, functionalities of the BNG being present close to the OLT, like in a edge, or centralized, for example, and the automated management. So there are different flavors, so to say, And as this picture shows, the software can be running close to, inside the device, and outside of the device in a server environment. Typically, more than one of these models are likely to coexist. So from operator perspective, it is not just the choice of the model, but also how to have a unified management to coexist with more than one of these models. But first, of course, which model to choose? Do I start with a smaller deployment? And in which case, do I need a lot of virtualization to begin with? Can I start with, let us say, an inbox model, a pay-as-you-grow kind of a model, and then as densities increase, should I go into virtualization? These could be some of the considerations between a inbox versus a virtualized model. Once that is decided, we will have to still look at the coexistence of these models. In this picture, the left-hand side, the first one, shows a traditional model where all the software runs inside the OLT, and the OLT would have a vendor proprietary interface, or it could have standardized interface. Coming to the disaggregated choices, option number 2 represents a similar one where it is disaggregated, as in the hardware is from the hardware partner, software is from a software ecosystem partner, but it runs inside the box. And the principles of open networking, it exposes open interfaces. In this case, the broadband forum netconf YANG interface for all the models. And then this can be taken up one step ahead with virtualization. In broadband forum, principles such as the WT 484, WT 477 are providing multiple options to virtualize. And WT 477, for example, specifies a semi-virtualized model where software can run partially inside the OLT and some functionalities with respect to the access management run as containers in a compute node. Likewise, the BNG functionality can also be co-located in some cases where it's a distributed edge, for example. So this forms here virtualized or semi-virtualized model. And model 4 is with the very popular ONF Ciba-Volta model, where the entire approach is disaggregated and virtualized, with the Volta providing hardware abstraction layer and ONOS and ONOS SDN apps providing the complete control plane functionality. One approach when an operator needs to consider more than one of these together is to use the open broadband abstraction layer. The open broadband abstraction layer, or the OBBAA, at a minimum provides a netconf to SNMP or netconf to any adaptation conversion. It of course provides a lot more functionality, but it could be as a management abstraction to integrate traditional and non-traditional, as well as, for example, Ciba-Volta based OLT models. At the management layer, we are able to look at all these different implementations in a unified manner, provision in a unified manner, which is what is required from an operator perspective. Let us now move on to have a closer look at the OLT functions. These functions do not change whether it is a traditional OLT or inbox OLT or a virtualized OLT, except for the fact that the location of the functions, basically it's a refactoring of functions inside the box or on a virtual container, for example. So on the left-hand side, I have depicted here on a physical OLT in an inbox model, all the PON management functions, the PON service models handled inside the OLT, and likewise the functions close to the network, including the layer 2 multicast, YM protection, timing sync, which need not be virtualized, and the fault alarms, performance, and telemetry functionalities close to the hardware as well. This exposes a standardized netconf interface as per the BBF-YANG models. And on the virtualization layer, the virtualized OLT control plane runs the access-specific protocols. These could be in virtual machines or, as the current approach is, with multiple containers, and depends upon the implementation whether all these functions or some of these functions are kept as containers. We also see, for example, the BNG functions, and it could be, say, inside the OLT, depending upon the hardware capabilities of the OLT, or in a separate TOR aggregation switch. The examples that Nanda mentioned, the leaf and the spine switches, with some of which can support a complete BNG functionality. So this is one model of realizing a OLT or a OLT plus BNG functionality in a disaggregated model or in a semi-virtualized model with these elements. Next, let us look at the management model. Rather, how has the management evolved or trying to evolve along with the disaggregation? This picture is about the traditional management system of the OLTs, which supports the device level or the element management, network management, and the OS as BSS functions. Traditionally, every OLT would come with its own element management system, a very powerful, intuitive, graphical user interface system, but that is tied to the operations of the particular vendor OLT. It might use proprietary interfaces or it might be standards based, but it is tied to the particular OLT system. One of the operator requirements is to have a unified view or a single management system that can manage multiple elements, multi-vendor, multi-service, multi-element, multi-level. And this is possible only with standardized and open interfaces. And to realize, because with the advantages of SDN and the SDN applications-based model, the need is to have a fully automated approach, an agile approach that can enable automation and other analytics collection, and the possibility to have intent-based provisioning. And the whole mechanism with respect to management and monitoring needs to be scalable. Here we are talking about a management system being able to handle a central office, a regional central office, geographical spread of OLTs, which could be of the order of a few tens of OLTs to a few hundreds of OLTs, and the number of subscribers associated with it. This leads to the newer paradigm with the management, where it needs to support physical network functions, virtual network functions, provide a SDN-based management with open interfaces such as netconf, REST APIs for automated management, and be able to be efficiently controlled by standard OSS BSS systems. End-to-end, with respect to the complete access and the edge network, that would be more than one management system. One that manages the access network elements and one that manages the edge network elements. This needs to be orchestrated at the next level by a domain orchestrator, but not always would there be a domain orchestrator that manages both the verticals. So it could be that the management system needs to provide all complete local management, which means management of the OLT the TOR switch, the TOR leaf spine, and to an extent the BNG functionalities as well. Basically, a complete self-contained management system, which also can grow to be managed by a domain orchestrator with full scale. We have the SD management system present SANS that provides both the configuration management and the monitoring management functionality. Laying these all together, if we look at it end to end, we discussed about the OLTs running in-box software or being virtualized. Likewise, the TOR leaf spine switches, they mostly would be running in-box model software. But when we are talking about the BNG functionality, the BNG functionality can be disaggregated as well, with the PFCP head of models in Broadband Forum WT459. So the software of the BNG control plane, it's disaggregated and runs on a compute node. So this principle of disaggregation combined with virtualization can indeed apply to any network element, and it purely depends upon the operator's use cases. The management system, along with the orchestration systems, will need to handle these diversity of requirements. With respect to orchestration, the system will need to handle, be it a virtual machine or container, a single container or a multi-container model, orchestrate them with a virtual infrastructure manager running either a VMware or a Red Hat OpenShift, any of these VIMs, and with an orchestrator such as ONAP, OSM, or any other third-party orchestrator tools. So from a operator perspective, you're deploying a new generation, next generation, disaggregated, virtualized OLT system comes with tying all these pieces together with this cloud central office, or the CORD model, as it has been called all these days. What does Capgemini bring in here? As we mentioned earlier, Capgemini provides the software that runs on different elements. The OLT, the network operating system, the NOS for the TOR, the leaf spine switches, the BNG, which could either be in the box or be virtualized. We also provide the management system, present SANS, for the access network elements, the multi-device, multi-element, multi-level management system. We work with different forums in the space, starting from the Broadband Forum, the OCP, the ONF, and the TIP. TIP especially has launched the fixed broadband, and which, with a focus both on the BNG and the OLT, we expect a lot more drive into the space, just like the other TIP programs that have been going on. And we are benefited by the rich partner ecosystem we work with, be it with the ONU, the OLT, or the aggregation and the BNGs, the hardware ODM partners with whom we closely cooperate. All this to the benefit of the operator community. And when we work with operators, it is the operator partner management systems. It could be the OSS, BSS systems, or the VIMs in the operator. So likewise, all this needs to be integrated together as one cohesive element, which is basically the challenge of putting together disaggregated systems and turning it into a working reality. Finally, with all the benefits of disaggregation, the challenge of making it into a functional reality is building the pieces together. As we say, the integration is the key to a successful disaggregation. And what we bring in here is the functionality with respect to the software, the mature partner ecosystem, the SI services, which is required to tie these pieces together, and the network consultancy with respect to the choice and building it with our partners.
Thank you, Kalimani and Nanda, for a very great presentation. So I have a few questions to both of you. Here is the first question to Nanda. So what are the cost benefits of deploying the disaggregated solution?
So yeah, so Satya, yeah, I think it's a good question. So customers or service providers encounter costs at two different levels. One is a capex, or the initial procurement of the equipment, and the other is the operational expense that they incur over the period of operating that equipment. So the capex is a day one cost. The disaggregated model for certain provides a level of cost benefit for the open hardware and the software the customer will deploy. But the major part of cost is the operating of the network, which is where the biggest benefit of disaggregation will be realized. The customers will be able to save on operating the network over a period of, say, 3 years or 5 years or 7 years. And this is where over the years that they will realize the biggest benefit. The reason being that the disaggregated model does not have any kind of hidden costs for introducing a new feature or introducing a new software release. So the customer deploys this once and continues the realize the cost benefits over many years.
Thank you, Nanda. My next question is to Kalimani. As an operator, what are the things should I consider before deploying the disaggregated solution?
Sure, Satya. I think this is another very relevant question. And I'm sure it's in the top of the minds of operators as they consider going the disaggregated model. And there is a lot of dependencies, obviously, like what we discussed. Let us start from the some parameters, like for example, the size of the network and the growth of the network year on year, and then whether it is a brownfield versus a greenfield. So these are some parameters which, for example, can help decide. The first question is whether I want to do a white box OLT, like the ones that we are discussing, versus a switch plus SFP based OLT, which is also a very good model from a pay and grow perspective. For example, you have a switch, and then you can populate SFPs as we need, and then also support active Ethernet, for example. That could be one. And then with the white box OLT model that we are discussing, it enables a different scale of deployment. So one can have the blade OLTs, a smaller number for a smaller footprint, obviously, and then enable technologies like stacking or virtual chassis, or with leaf span aggregation. Different approaches realize the chassis kind of a model. So these are some approaches. Again, one can overlay whether an inbox model is required or a virtualized model is required. This again is a very, I would say, important or a touchy topic, depending upon the field staff preferences of the operator. While virtualization is a very sought after, desired approach, because of practical considerations, which could be as simple as installing another compute node and the location of the compute node. Should it be co-located with the OLT, or should it be distant? And if it is distant, which of the protocols can be virtualized? So these considerations might make the operator decide whether I want to do a inbox model versus a virtualized model, or the semi-virtualized model that we talked about, where much of the performance critical and the network dependent functions still reside inside the box. So these are some of the parameters with which one can try to decide upon what kind of a solution architecture one needs to go with. And then when it comes to deciding the solution, it's about the ecosystem. The hardware vendor, the software vendor, the stability of the roadmaps, and how tightly it is integrated, how tightly it is qualified, interoperated. And again, as we were talking about the tip fibber, so we would possibly see is similar to the DCHG approaches to the OLT, also OLT in the BNG, requests and other approaches, where operators can get a first-hand view of solutions that are pre-integrated and available. So these are some of the approaches that operators can use to gauge the right solution.
Thank you, Kalimani. So now I have the question to both of you, Nanda and Kalimani. So this question is, on what basis as an operator should I select a vendor for the disaggregated solution?
So Kalimani, you may want to take that first.
I somehow think I kind of partially answered the question, so it's kind of continuity. So maybe I would touch upon a few more points. So as I said, the choice of the architecture model, whether the vendor supports it, the roadmap, the integration, those are some of the points that I mentioned earlier. But in addition, so we covered in today's presentation that the access is not just about the OLT, it's also about, let us say, a TOR switch, or maybe a leaf spine switch, the end-to-end, and then also about the management, unified management. So those things can also factor in to the equation, because finally, from operator perspective, it is not about a box, it is not about an independent software, but it's about the service. A HSI service, a VoIP, video, IPTV multicast, business VPNs, ELAN, ELAN, L2 VPN, L3 VPN, all these services from the OLT, all managed seamlessly, and being able to provision for a number of subscribers, for example, in a single pane of glass. So, and these have been happening in the traditional OLTs successfully. And with the disaggregated solution, the added benefits, for example, with the SDN-based management, with automation, intent-based configuration, analytics. So from a deployment perspective, am I getting all these advantages well stitched together in order to make a successful rollout? So it's not just about the technology and the ability to roll out, but the long-term perspective of being able to maintain it, being able to support it. And as Nanda mentioned earlier, it is not just about the initial capex, but the opex. Only when we have a well-stitched and maintained system, which can be debugged, troubleshooted, and managed, can the opex be under control. I think this is another important factor to select a wholesome disaggregated solution. Over to you.
Yeah, excellent points, Kalimani. The only thing I would like to add is a couple of fundamental, just as far as the hardware is concerned, we just focus on fundamentals that the hardware should just be of carrier grade quality. It has to have the best in class performance. Essentially, it should exceed the requirements of the service providers. So disaggregation does not mean in any way that your performance or the quality goes down. In fact, it has to be better than what the service providers are used to. So yeah, that would be one. And the second point that I would also like to briefly mention is that, and touch upon what you already said, pick solutions that will not go away tomorrow. I mean, they are backed by sound business models that once you deploy, the support and the technical assistance for that will be available for you, not just the next year, but several years down the road when when you want to operate that equipment, manage it, and realize provide services to your end customers. So these will be the key points. And Satya, go ahead. I think those are the points I wanted to add.
Yeah, I agree.
Thank you. Thank you, Nanda, and thank you, Kalimani. So audience, if you have any further questions, please feel free to reach out to Nanda and Kalimani to them. So they will be more than happy to reply to you. Thank you.
Thank you.
Thank you, everyone. Thanks, Kalimani, Satya.
Thank you, everyone. Thank you.